Now, I welcome Mr. Sanjeev Garu, PGT working at TSMS Shankarampet Art. In his previous class, he dealt with circles of mathematics of 2B. Sanjeev Garu, please continue the session.
Thank you, madam. Kindly make me as a co-host so that I can enable my screen. No, I have been disabled for sharing the screen now. Yeah, thank you. Good morning, students. So last class we have discussed many number of things regarding the circles. We expected that I expected that you all solved problems which I have given as assignment. Hope that you all have solved the problems, and I appeal all of you, if at all you have got any problem, you shift your screen in a horizontal mode so that you can see the entire screen. Okay, so today's topic is the position of a point in a plane of a circle. So before discussing what exactly is today's topic, we'll go for what you have discussed in the previous class. So we have discussed about what exactly is secant, what is a chord, and what is the diameter of a circle. Then we discussed about what exactly is the equation of circle when you know the extreme points of the diameter. X minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. Then we have discussed what exactly is the parametric equation of circle. X is equal to h plus r cos theta, y is equal to k plus r sin theta, where h and k are the values of the center, and r is the radius, theta is the angle made by the ray from the x-axis. Then we discussed about what is the equation of circle when three non-collinear points are given. So we take the standard equation of circle, substitute the 3 points and satisfy the equation. Then we discussed about what exactly is concyclic points. So when you got all the points lying on the same circle, then you have called the points as concyclic points. Then we discussed about equation of circumcircle. Right, so these are the concepts which we have discussed. These some problems we have discussed on these models. Now today we just start with the second session, position of the point in a plane. Now we need to introduce some standard notations which are used in circles. The first one. Now see here, you got equation, the expression as x square plus y square plus 2gx plus 2fy plus c. Now, do you recollect this expression x square plus y square plus 2gx plus 2fy plus c? Now, when you have equated to 0, you have called this as equation of circle. So instead of calling every time this x square plus y square plus 2gx plus 2fy plus c, we can represent by capital S. And this is what is the equivalent symbol. Now, we introduce a symbol called as S1, S subscript 1. So this equation is x, this expression is x1 plus y1 plus g into x plus x1 plus f into y plus y1 is equal to 0. So instead of calling every time this entire expression, we can simply call S1. Likewise, we have got S2. It is x into x2 plus y into y2 plus g into x plus x2 plus f into y plus y2 plus c. X2 plus y2 plus g into x plus x2 plus f into y plus y2 plus c. Then we got an expression S12. It is given as x1 x2 plus y1 y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c. Then we got another expression S11, x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. So out of all these expressions, the first expression, the second expression, and the last expression which you have chosen, they are used widely the entire circles topic hereafter. Okay, so what is S? Expression S is nothing but x square plus y square plus 2gx plus 2fy plus c. What is S1? Xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c. And what is S11? It is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Just compare this first expression and the last expression here. So you are replace x with x1 and y with y1 everywhere. So these are the standard notations which you are using in expressing the circles, tangents, length of the tangents, chords, and many more. So for example, if you take this one, first one, x square plus y square plus 2gx plus 2fy plus c is equal to 0. So what did you call this as? We have called it as standard equation of circle. So instead of calling this entire term, we can write the equation of circle as simply s is equal to 0. So when you write s is equal to 0, it means that you have written the entire expression. So instead of writing this entire expression, and straight away you can write s is equal to 0 for this terms. So the equation of circle now we can write as simply s is equal to 0. Now we start with actually the point or the presentation which I started with. So what exactly is position of the point with respect to a circle? So once you take a circle here, so generally a circle divides the plane into three parts. One part is something like called as interior of the circle. See that here inside the circle you can have points. So position of points, the points can be inside of the circle. So any point inside is what is called as interior of the circle. Then you call circumference of the circle. So any point on the boundary of the circle here, all the boundaries of circle, if at all you take points, these are called as circumference of circle. And third one, it is what is called as exterior of the circle. So in the plane, except the circle, remaining all part is what is called as exterior. So we can divide it as interior of circle, circumference of circle, exterior of circle. Not only circle, you can take any object, any closed object, we can define it as interior, circumference, and exterior. So interior of circle means it is inside the circle. Circumference of circle means on the boundary of the circle. Exterior of circle means outside the circle, everywhere in the plane. Okay. Now we just continue with the concept here. If you take a circle, now I'm calling a circle as s is equal to 0. Now what exactly is s is equal to 0? It is x square plus y square plus 2gx plus 2fy plus c. And you have taken a point which are called as px1, x1, y1. The point and circle are in the same plane. So if you take the point, you can say the point lies in the interior of circle if the value of S11 is less than 0. So what is S11? S11 is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. So if you get the value of S11 is less than 0, you say the point is interior of the circle. Now just if you take the point lying on the circle, then the value of S11 is 0. So you see the difference. If it is interior of circle, the value of S11 is less than 0. If the point lies on the circle, the value of S11 is equal to 0. Now, if you take the point outside the circle, then what is going to happen? The value of S11 should be greater than 0. So we got three conditions here. If the point P lies inside the circle or interior of circle, the value of S11 should be less than 0. If the P lies on the circle, the value of S11 is equal to 0. And if the point P lies in the exterior of circle, the value of S11 is greater than 0. So let us try to prove this statement. We take a circle equation, and the center of circle generally take it as minus g minus f, and radius of circle we take it as square root of g square plus f square minus c. And you have taken a point P, which you are calling it as x1 y1. So you have taken s is equal to 0, then center, radius, and the point. Okay, now we take up the first thing. So first case, what you observe, where is the point here? The point is inside the circle, isn't it so? The P is inside the circle. So when you draw a line between C and P, this line, distance between the C and P will be always less than the radius. So you can say if the point lies in the interior of the circle, the distance CP is less than R. So distance CP is less than R. What is our radius of circle? Now, if you take squares on both sides, then you can say CP square is less than R square. So how to find CP square? So you know how to find the distance between 2 points. One point is C minus G minus F. Second point is P x1 y1. So you got a formula. Use that formula. You can write it as x1 minus of minus. So it is x1 plus G whole square plus y1 minus of minus f, so y1 plus f whole square is less than, what is the radius of the circle? Radius of circle, you have taken it as g square plus f square minus c under root. So if you take r square, then no need of writing a root. So it is simply g square plus f square minus c. So you can write x1 plus g whole square plus y1 plus f whole square is less than g square plus f square minus c. So we try to expand this x1 plus g whole square and y1 plus f whole square, and bring this g square plus f square minus c onto the left hand side. So what is going to happen? So the first term you get is x1 square plus 2gx1 plus g square. Likewise, y1 square plus 2f(y1) plus f square. Now, because you're getting g square, f square, c other side, so you get minus g square minus f square plus c. The sign is less than, again, 0. Now, you have got a g square and a minus g square. So you can cancel it out. So can you cancel plus g square and minus g square? Now, what about f square and minus f square? You can cancel it off. So the g square term will cancel with the g square term, and f square term will cancel with f square term. So what is going to happen? You'll not have any g square term, you'll not have any f square term. So the equation reduces to x1 square plus y1 square plus 2gx1 plus 2f(y1) plus c is less than 0. So what is that expression? x1 square plus y1 square plus 2gx1 plus 2f(y1) plus c. We have called it as S11. So you can say S11 is less than 0. So once you got the point P lying inside the circle, then the value of S11 is less than 0. Now let us try to prove the remaining two cases. So once just observe here, what you got is CP is less than R. Why you have used less than symbol? Because the radius is always smaller than the distance between any point from center to point inside the circle. So the CP is always less than R. So because of that, you got this condition. Now, second condition you take, what is second condition? If the P lies on the circle, the value of S11 is equal to 0. So P is on the circle. So you observe the circle here, center is C and P is lying on the C. So what is CP? It is distance between C and P. Now, can you call this as Radius? Yes. So distance between the center and any point on the circle is always called as radius. So we got the value of Cp as equal to R. So as usual, like previous steps, you can follow here. You can write Cp square is equal to R square. So again, Cp square, if at all you just take the same terms, so it is x1 plus g whole square plus y1 plus f whole square is equal to radius square is g square plus f square minus c. Like the previous proof, here also expand it here, x1 plus g whole square and y1 plus f whole square, bring this g square plus f square minus c on the left hand side. What you get is x1 square plus 2gx1 plus g square plus y1 square plus 2f(y1) plus f square minus g square, because it is plus here, other side goes as minus, minus f square, and because it is minus here, other side goes as plus c is equal to 0. Now again you can cancel off g square and minus g square, f square and minus f square. So the equation will reduce to again x1 square plus y1 square plus 2gx1 plus 2f(y1) plus c. So every time equal to is there, so equal to will come here, equal to 0. So again this expression is x1 square plus y1 square plus 2gx1 plus 2f(y1) plus c is, it is S11 is equal to 0. So S11 is expression and is equal to 0. So if the point lies on the circle, the value of S11 is equal to 0. So let us take the third case, if the point P lies on the exterior of the circle. So you see that this is what is circle. Where is the point you observe here? It is not inside the circle. It is not on the circle. It is outside the circle. Okay. So because it is outside the circle, you call it as exterior of circle. Now you see this Cp is bigger than the radius of circle. Okay. So distance Cp is bigger than the radius of circle. So what is the expression you can write now here? Cp is greater than R. Cp is greater than R. We can write Cp is greater than R. Okay. So you can write Cp square is greater than R square. So again, we can use the similar sort of expansion. X1 plus g whole square plus y1 plus f whole square is greater than g square plus f square minus c. Bring this everything one side and expand this. So we get x1 square plus 2gx1 plus g square plus y1 square plus 2f(y1) plus f square minus g square minus f square plus c. This time it is greater than 0, because you have got everything other side, you get nothing is left out, it is greater than c. So you can cancel off f square, g square. You get again the expression x1 square plus y1 square plus 2gx1 plus 2f(y1) plus c. This time it is greater than 0. So this expression already have called as S11. So you can write S11 is greater than 0. So if the point lies in the exterior of circle, you will have the value of S11 is greater than 0. So if the point lies inside the circle, S11 is less than 0. If the point lies on the circle, the value of S11 is equal to 0. If the point lies outside the circle, then the value of S11 is greater than 0. Okay, so children, have you understood this theorem? So to copy this, actually you can take a screenshot or you can revisit this video again. Okay, so let us take a small example, right? So we have taken a circle equation here as x square plus y square plus 6x plus 8y minus 96 is equal to 0. Now we have taken a point 1, 2 and another point 4, 5. So what you are going to do is we are going to locate the position of the points on s is equal to 0. So whether it is in the interior of circle, whether it is in the exterior of circle, or whether it is in the circle. So what is the circle equation? X square plus y square plus 6x plus 8y minus 96 is equal to 0. So how is that you know that, what is the method to know whether it is lying inside or outside or on the circle? All three you have got S11. So you are going to find what is the value of S11. So what is S11? It is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Right? It is an expression. I'm not writing it as equal to 0. Now here, if at all you equate to 0, it is going to become an equation. So expression is S11, right? Now, the first point you take. What is the first point here? 1, 2. So what do you have to do here? You have to replace the value of x1 with 1 and y1 with 2. So you substitute the point 1, 2 in the equation, in the expression 1. It is not equation, it is expression 1. Right. So once you just say it is substituted, the value of x is 1, the value of y is 2. So you can write x1 square, y1 square, g value is 6, f value is 8, and c value is minus 96. As it is, you have copied here. x1 value is 1, y1 value is 2, then 6 is g value, x1 value is 1, 8 is f value, and y1 value is 2 here, and c value is minus 96. So 1 square is 1, 2 square is 4, 6 into 1 is 6, 8 into 2 is 16, and minus 96. So when you expand, when you simplify this, it is going to be minus 69. So minus 69, is it greater than 0 or less than 0 or equal to 0? So definitely it is going to be less than 0. So once it is less than 0, what is it you conclude? Whether the point is inside interior of circle, on the circle, or exterior of circle. So what you got is S11 value is less than 0. So if S11 value is less than 0, what is the conclusion you had? The point lies in the interior of circle. So you can say P1, 2 lies in the interior of the circle. S is equal to 0. Now you take second point. What is second point? 4, 5. You have to again check whether it is lying in the interior of circle, exterior of circle, or on the circle. So you again substitute the 4, 5 in the equation. Substitute and tell me. X value is 4, Y value is 5, G value is 6, F value is 8, and C value is minus 96. So you get 4 square plus 5 square plus 6 into 4 plus 8 into 5 minus 96. So what is the value you are going to get? Is it greater than 0 or less than 0 or equal to 0? You observe that answer is 9. 9 is always greater than 0. So once it is greater than 0, so the value of S11 is greater than 0. So what is the meaning of it? The meaning of it is the point lies on the exterior of the circle. So if you got S11 less than 0, it is interior. If the value is greater than 0, S11 greater than 0, it is exterior. So have you followed this? So let us take another problem. Locate the position of the point 0, 0 on the circle. Now you observe the circle. What is a circle here? X square plus y square minus 3x plus 4y is equal to 0. Now, what is the specialty of this equation here? What is it you observed? There is x square term, there is a y square term, x term, and y term. There is no constant. We know that whenever you don't have any constant in the equation of circle, definitely the circle passes through the origin. Okay, so it has to satisfy the equation. So when you substitute 0, 0 in the equation of circle, what is going to happen? P 0, 0. So we got S11 is equal to 0. So the reason for getting S11 is equal to 0 is because you don't have any constant and the point was origin. So because the point is origin, definitely this circle passes through origin. There is no constant you observe here. So whenever you don't have any constant in the equation of circle, the circle is always passing through the origin. This is what you learned in the first class. So let us introduce a very, very important concept called as tangent. Tangent of a circle. So what is tangent? So before discussing about tangent, so we just revisit what exactly is secant. So if you take a point P, you see that there's a point P here. You have seen that point is here, and Q is a neighboring point of P. So it means that the point Q is near to P, right? Now you join this with a line. What did you call the line PQ as? We have called it as secant. So the line PQ is called as secant. Now you fix this point P, move this point Q this side. What is going to happen? Onto the left side, you can see I'm just pointing the pointer here. If at all it is moved on the left side, the PQ is going to, the length of the PQ is going to increase. If at all you move on the right side, what is going to happen? The point Q will be coming closer and closer to P. So if you take the PQ here, if it is moved from this point to this point, what is going to happen? This length has decreased, PQ length has decreased. Further it is moved, then further it is going to decrease. If you move it further, further it is going to decrease. So if at all this Q, Q1, Q3 goes on, if this point comes nearer and nearer, then this Q values will approach this point P. So you see that the Qs are approaching P. So what is it you observed? This line has become a line which touches the circle at only one point. So the limiting position of the line. So what do you mean by limiting position of the line? Means once you move this secant closer and closer, as Q is approaching P, as the point Q is coming nearer and nearer to P along this circle. So how is it you move it? You move along this circle, right? This line is what is called as tangent. So the limiting position of secant PQ when Q tends to P or Q approaches P along the circle is called the tangent at P. So this line PT is what is called as tangent. And the distance between the P and T is what is called as length of the tangent at the point, from the point T. So the line PT is called as tangent. See, when you say line, you can extend on both sides. So the line is tangent. So what is that you have done? The secant can be made as tangent once you move this one of the point, keeping the second point as fixed along the circle, the secant is going to become tangent. So the secant PQ has become the tangent. So have you understood this here? Right? So if you take a point on a circle and Q is a neighboring point of P on the circle, the line segment PQ is called as secant. So it's called as secant. The limiting position of line. What do you mean by limiting position of the line means? So one of the point is fixed. This is moving. When you say limiting position, it means that one is moving. So the line PQ, as Q is approaching P, as Q is coming near and near to the P here, then the limiting position is called the tangent at P. So limiting position of line PQ when Q approaches P along the circle is called tangent at P. So the line PT is called as tangent, and PT is, here I put a bar, it means that it is line. Here I not put anything here. So it is simply a value. So PT is a length of the tangent from point T. So like, have you understood this here? So if you understood, then we can go for the next thing. Now, what exactly is a power of the point? So introduce the next term called as power of the point. So we take a circle S is equal to 0 with center C and radius R, and you have taken a point P x1, y1. Now the value Cp square minus R square. So what is Cp square? It is distance from C to P. So Cp square minus R square is defined as power of P with respect to circle S is equal to 0. So if you take S is equal to 0 a circle with center as C, radius as R, and P is any point. The value Cp square minus R square, Cp square minus R square is called as power of P for the circle S is equal to 0. So we can say with respect to circle S is equal to 0. So Cp square minus R square is defined as power of P with respect to circle S is equal to 0. Now, what is the value of Cp square minus R square? It can be negative, it can be positive, it can be equal to 0. So if the power of point is negative, 0 or positive, depending on the position of the point lying in the interior on or exterior of the circle. So if it is interior of circle, what is that you get? The value of Cp square minus R square is less than 0. So why you're getting less than 0? See here, Cp square minus R square. It is, the point is inside. So when you take Cp square minus R square, definitely the value, because Cp square is less than R square, Cp square minus R square is always going to be less than 0. Now, if at all the point is on the circle, so the power of the point is 0 if it is on the circle. So when it is on the circle here, the point is on the circle, the Cp square minus R square is going to be 0. So Cp square minus R square is 0 if the point is on the circle. If the Cp square minus R square or the power of the point is positive, means that the point you have taken is outside the circle or exterior of circle. So you observe that the point is outside. So because the point is outside, the value of Cp square minus R square is greater than 0. So I repeat this point. If P is a point, the power of the point is negative, 0 or positive, depending on the position of the point lying in the interior. If it is interior, it is negative. If it is on the circle, it is 0. If it is outside the circle, it is positive. It is positive if it is outside the circle. Okay, so you got 3 conditions which you got. Now there is one more statement. If at all you take the power of the point with respect to circle S is equal to 0. The power of the point with respect to circle S is equal to 0 is S11. So already you have taken the theorem earlier, Cp square minus R square, either it is less than 0 or equal to 0 or greater than 0. So you are now calling the value of Cp square minus R square as simply S11. So the power of the point we have defined as Cp square minus R square and its value is S11. So let us try to prove this statement here. We have taken a circle, S is equal to 0, center minus G minus F, and radius root over G square plus F square minus C. So center is minus G minus F and R is root over G square plus F square minus C. So what you have to show? You have to show that the power of the point, that means that Cp square minus R square should be equal to S11. So for that, we start with the left-hand side. So Cp square minus R square. So what is the value of Cp? Can you tell? Cp square. Cp square is the distance, square of the distance from the point C and P. So how to find Cp square? So it is x1 plus g whole square, y plus, because already c is having negative sign. So x1 plus g whole square plus y1 plus f whole square minus g square plus f square minus c. So expand this. So again it is x1 square plus 2gx1 plus g square plus y1 square plus 2fy1 plus f square minus g square minus f square minus c. So you can cancel off g square f square. G square will cancel to minus g square. F square will cancel to minus f square. You will reduce the equation to simply x1 square plus y1 square plus 2gx1 plus 2fy1 plus c is equal to 0. So This term we have called as S11 already. So what is it you conclude? Cp square minus r square is nothing but S11. So the power of the point is S11. So power of point P with respect to circle S is equal to 0 is S11. So definition wise, the power of the point is Cp square minus r square. But in practice, the power of the point, we take it as S11. Okay. So let us take another situation. Now you take a circle, S is equal to 0 and Px1, y1 be a point on the plane. Now what is that you observe? The line P meets the circle at 2 points. You see the point P here and it is meeting the circle at point A as well as point B. So we can claim that if a line through P meets a circle at A and B, then the power of the point is nothing but simply multiply PA and PB. So the product of distance between P and A and distance between P and B is nothing but the power of the point. So the power of point, now you got three formulas. What is that? The first one is Cp square minus r square. Second one is S11. And if you got a point P here and a line cutting the circle at 2 points, the distance between P and A and distance between P and B is always equal to power of the point. Now, very, very important, where is it you observe? The point is lying outside the circle. Now, if the point lies on the circle, so what is going to happen? The distance between P and A is going to be equal to 0 because P and the point P is here. The point P is here. If the point P is here, then you'll have PA as equal to 0. So definitely the value is going to be 0. So the power of the point is 0. So once the power of the point is 0 means its value is S11 is 0. Now if you take the point P here, the point is inside. What is going to happen? You will get the value of PA not possible. So definitely the point P cannot lie inside the circle. So it can be either outside the circle or on the circle. Okay, now let us take one more definition. It is what is called as length of the tangent. So what exactly is length of the tangent? So once you take a circle and point P x1 y1 and the point is lying outside. Now here see that this line is there. Now as this B is approaching A, what is going to happen? This B is going to be A. So actually AB is a secant. As the B tends to A, then this line, whatever you got, is going to become a tangent. Definition of tangent. So the secant is going to become tangent as the point B comes closer and closer to A. So once B comes closer and closer to A, then what you get is the length of the tangent is square root of S1. See here, if you got A is equal to B, as B tends to A is going to become B or B is going to become A. So you have only 1 point, not 2 points. So this line PA can be called as tangent. But what is the power of the point formula here? It is PA into PB. Because A is equal to B here, you can write PA into PA. But power of the point, you have got a formula as S11. So you can write PA into PA is S11. So you can say PA square is equal to S11 or PA is nothing but square root of S11. So very, very important point. What is the length of the tangent from an external point to the circle? It is going to be square root of S11. Now, if you got the point exactly on the circle, so what is going to happen? Distance between PA, the distance between P and A is going to be 0. So it means that the value of S11 is going to be 0. Once S11 is equal to 0, then definitely there is not going to be any tangent. Okay, so practically not possible here. Now, if at all you take the point P inside the circle, then there is no possibility of having any tangent. So depending on the position of P here, we can say the length of the tangent is given as square root of S11. So the point is exterior point only, right? So length of the tangent from an exterior point P to the circle is given as square root of S11. Okay, so let us take a problem here. There is a point called as 3, 4, and you got a circle, the expression x square plus y square minus 4x minus 6y minus 12. So you are going to locate the position of P with respect to circle S is equal to 0. So if you equate to 0, it is called a circle. It is an expression here. So you are going to see where is the position. And you're going to find the power of the point with respect to circle S is equal to 0. And you're going to find the length of the tangent from the point to the circle. So for this point, for this expression, we are going to locate the position of the point. We are going to find the power of the point. We are going to find the length of the tangent. So let us take the first one. So what is given here? Equation of circle. Equation of circle given as S is equal to 0. So x square plus y square minus 4x minus 6y minus 12. And what is the point given? 3, 4. So what is the value of 2g? Minus 4, 2f minus 6, and the value of c is minus 12. So from that, you can get the value of g, f, c. Okay, so once you get the value of g, f, c, what is going to be the center? The center we know it as minus g minus f. So g value is minus 2, f value is minus 3. So center is going to be 2, 3. Radius, we know the formula as root over g square plus f square minus c. So g value is minus 2, f value is minus 3. So you get minus 2 whole square plus minus 3 whole square minus of minus 12. So it is going to be 5. So the distance between C and P, if you take distance CP, so you got C as 2, 3 and P as 3, 4. So how to find distance? You got a formula, square root of x2 minus x1 whole square plus y2 minus y1 whole square. So here it is 3 minus 2 whole square plus 4 minus 3 whole square. So it is going to be 3 minus 2 is 1. 4 minus 3 is 1. So 1 square plus 1 square. 1 square is 1. 1 square is 1. So 1 plus 1 is 2. So CP is square root of 2. So what is CP square? Square of the root 2. So square of 2 is 2. Right. So now you take what is the first one. So locate the position of the point. So when you take the first one here, what is the first point here? The point is given as 3, 4. So S11 is given as x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. So put x1 is equal to 3 and y1 is equal to 4 and substitute what is already observed. The answer is minus. So once it is minus, S11 is less than 0. So what is the meaning of it? As you discussed earlier, the point lies in the interior of the circle. So the position of the point with respect to circle is the point is in the inside of the circle. Now we're going to discuss what is the power of the point. What is the power of the point? Basic definition, it is Cp square minus r square. So Cp square minus r square, you see here, it is Cp square. Cp square is 2 and r square is 5 square. So it is 2 minus 25. So 2 minus 25 is minus 23. So what is already observed here? The power of the point with respect to circle here is negative. Now, if you got the value of the power of the point as negative, so it means that the value of S11 is also less than 0 here, already mentioned here, S11 is less than 0. So as I said, S11 is less than 0, the point lies in the interior of circle. So once you got the point inside the circle, there is no possibility of having a tangent. So the tangent is not possible as the point lies in the interior of circle. So if at all you got a point lying inside the circle, definitely there is no possibility of having a tangent. So tangent is only possible when the point is lying outside the circle or it is lying exactly on the circle. So if at all you just go through this problem here, if you have followed this problem, so I have got an exercise from the textbook, exercise 1B. You can take the snapshot of this. What is the problem about? It is actually locate the position of P with respect to circle. Likewise, find the power of the point P with respect to circle and find the length of the tangent from P to the circle S is equal to 0. So all these three type of problems I have covered in one single problem. You can see here the previous problem is of that kind. So locate the position of the point, find the power of the point, and find the length of the tangent. So we can practice on this. If you make a good amount of practice, then easily you can understand this concept very clearly, so that it becomes easy for you for the learning of next concept. So I feel that you understood it here. So you can take the snapshot of this page. So I'm going to go for the next slide. Now we got a problem here. If a point P is moving such that length of the tangents drawn from P to the circles x square plus y square plus 8x plus 12y plus 15 is equal to 0 and x square plus y square minus 4x minus 6y minus 12 is equal to 0 are equal, then find the equation of the locus of P. So what is the question? First try to understand. So you got a point. How the point is behaving? The point is moving. How it is moving? It is moving in such a way that the tangent here and the tangent here are of same length from this point. See here, you got a circle 1 and circle 2. You see here, this PT1 is a tangent to the first circle. PT2 is a tangent to the circle, second circle. This point P is moving. Whenever it is moving, whenever this point is moving, it is ensuring that PT1 and PT2 are equal. So we have taken S is equal to circle equation, S dash is equal to second circle equation. Let P x1 y1 is any point on the locus and PT1 and PT2 are the lengths of the tangents from the two circles. Okay, so once you got this, so what is the condition here? Lengths of tangents are equal. So it means that the PT1 is equal to PT2. So you can write squaring on both sides. PT1 whole square is equal to PT2 whole square. So how to find the PT1 value, PT2 whole square value? It is same as S11. So PT1 is nothing but length of tangent. So what is the formula of length of tangent? It is S11, right? Square root of S11, but because you have taken square here, the square root will vanish and simply get PT1. So length of tangent is square root of S11, but you have taken a square here. So it is going to be simply S11. And PT2 square is S11 with the second point. Okay, so you can say it is S11 and second circle you called as S dash. So it is S dash 11. So we did the same thing here. We simply replace x with x1 and y with y1 in both the equations. So we got the first equation x1 square plus y1 square plus 8x1 plus 12y1 plus 15 is equal to second equation x1 square plus y1 square minus 4x1 minus 6y1 minus 12, right? Now these two are equal. So how is it you simplify this? So bring everything on one side. So you get x1 everything one side, you because you got x1 square and x1 square, x1 square on both sides get cancelled, y1 square get cancelled off. So there is no x1 square, there is no y1 square. This minus 4 comes other side as plus 4. This minus 6 comes this side, the other side as plus 6, and minus 12 other side as plus 12. So you got the equation as 8x1 plus 12y1 plus 15 plus 4x1 plus 6y1 plus 12 is equal to 0. So you got 8x1, 4x1. So what should be the value here? 8 plus 4 is 12. 12y1 and 6y1, it is going to be 18. 15 plus 12 is 27. So you get 12x1 plus 18y1 plus 27 is equal to 0. So do you find anything common here? 3 is common. Remove that 3 common. So divide by 3, 4x1 plus 6y1 plus 9 is equal to 0. So you got the required expression. So the locus of the point is, so simply drop the x1 and y1, write it as x and y. So you get the equation as 4x plus 6y plus 9 is equal to 0. So if this point is moving, the point should be moving along a straight line, because this is a straight line, isn't it also? So whenever, even if at all you change the position of the point P here, it goes as a straight line only. It will not go as a circle. So it goes along a line. So whatever the line it has fixed, it goes along that line only. So you're going to get the locus as a line, right? So hope that you understood this problem here. Let us take one more problem. If the length of the tangent from the point 2, 5 to the circle, x square plus y square minus 5x plus 4y plus k is equal to 0 is square root of 37, find the value of k. So what is given here? Equation of circle. Now in the equation of circle, you don't have k. You don't have a constant. Constant is given as k. So you're going to find this value. And what is given? Length of tangent is given as root 37. Point is given as 2, 5. So you got tangent here. This length is given as root 37. And this point is given as 2, 5. And this equation of circle is given with unknown k. So we know that what is the length of the tangent? The length of tangent formula is square root of S11. So square root of S11 is equal to root 37. So you just remove the squares, you get S11 is equal to 37. So squaring on both sides you can do, or remove the squares you can do it. So S11 is equal to 37. So what is S11? S11 is actually x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. So here x1 is 2 and y1 is 5. So substitute that. So we can write 2 square plus 5 square plus minus 5 into 2 plus 4 into 5 plus k is equal to 37. So when you simplify this, 4 plus 25 minus 10 plus 20 plus k is equal to 37. So you can write the simplification as 39 plus k is equal to 37, or k value is 37 minus 39, which is equal to minus 2. So I hope that you understood. This is one of the examination question which can be asked for 2 marks. So I have given some 2 problems based on the previous 2 problems. If the length of the tangent is given as 1, find the value of k. And here, second one, the P moves as that the lengths of tangents drawn from P to the circles are in the ratio 2:3. So if you take T1 and T2 as points on circles, PT1 is to PT2 is 2:3. Okay, so the hint is PT1 is to PT2 is 2:3. So you can write PT1 by PT2 as 2/3. Cross multiply and solve like the previous problem, you get the answer. So you see the difference and tell me what exactly is the answer in the next class. So hope that you understood the today's topic, right? So what exactly you have learned today? So you have learned about the standard notations. You introduce standard notations of circles, then tangent, then S11 length of tangent square, power of point, and goes on. So you have taken position of point with respect to circle, whether it is inside circle, on the surface of circle, or exterior of the circle. Then you introduce the power of the point with respect to circle. The power of the point is given as Cp square minus R square. Definition wise, you can call it as S11. You can also call it as PA into PB. And you introduce what exactly is tangent and what is the length of the tangent. Length of the tangent is square root of S11. And we have solved some basic problems based on this. So with this, I conclude my session, and I'm ready for any sort of questions asked.
There are no questions in the chat, on the chat box.
Okay.
Thank you, sir.
Thank you very much. Thank everyone for giving me the opportunity once again. Tomorrow's class, it will be something like the concept of tangents and normals.
Okay, sir. Thank you.
If there is no queries, then I'll stop sharing the screen.
Yes, sir. No queries. Students, just practice the problems today the sir has discussed. It's not like just listening, just do lots of practice.
Hello, I'm not able to hear now. Sorry. Hello?
No, sir. I'm just advising students to do practice.
Okay. So I just forgot to actually I removed the microphone, headphones.
Thank you for the day, sir.
Okay, thanks a lot for giving the opportunity. I thank the management and especially principal madam, my principal madam, Sridevi madam, to actually guide me in presenting this class in a proper way. Thank you.
Oh, welcome, sir. Students, tomorrow also we'll have the same session continued by Sanjeev Kumar sir, as well as you have a botany session also. Thank you for the day.